Welcome. This is Carrie Dayton, your host for today's Analytic and Data TechCast, which will be immediately following this brief introduction. We have two great speakers today, Malia Namale, who is a product manager at Oracle. She has vast experience in multiple technology areas related to unstructured and semi-structured data management. Her current focus areas are graphs, Apache Kafka, and big data. She works closely with customers as they deploy solutions using Oracle products. She is a regular presenter at Oracle Open World and other industry events. We also have a second presenter joining us today, Stanika Delikova, who is a software engineer with PaySafe, and she's been working with them for the last 15 years. She's happy to be part of an organization from the start and see it grow. During this long journey, she has gained experience in different technologies and business aspects. Together, they're both going to present graphs, database, and analytics, after which we'll have a brief question and answer period. We have some upcoming TechCasts coming. Next March, on March 12th, Thursday, March 12th, we have First Steps with Oracle Autonomous Transaction Processing with Rita Nunez. Don't forget to visit our website and watch past TechCasts and download slide decks from previous speakers. The speaker's contact information is in the presentation, which is being recorded and will be available on our TechCast page shortly following this TechCast. We will also post a PDF of the presentation on the same website. And don't forget, we have a YouTube channel where we will be posting the TechCast, and you can see all of the other past TechCasts on the YouTube channel, hashtag #AND_TechCast. Everyone who has knowledge, expertise, tips, and tricks are encouraged to share your information and tricks with us. Please consider submitting an abstract and a proposal for one of these TechCasts, and you can do so by visiting the Analytics and Data Summit website. At the end of our speaker's presentation today, they will have a list of helpful links. These links will appear also in the comments section during this TechCast. Please don't forget to submit your questions through the question and answer buttons. Our speaker will answer them for you during the presentation if there is time. If not, they will email you following the presentation as long as you've submitted your questions through the question and answer section. Don't forget, if you like this topic and so much more in Oracle technologies, please consider joining us next week at the Analytics and Data Summit, which is being held February 25th to the 27th next week at the Oracle Santa Clara campus. It'll be a great time. It's a wonderful, intimate conference, and we really hope to see all of you there. All Analytics and Data TechCast should take about 30 minutes, including the end of question and answers, but it's all based on question and answer submissions. So please don't forget to submit your questions through the Q&A window so that we can be tracked and answered by the speakers. With no further ado, I would like to go ahead and turn it over to Melly. Welcome.
Thank you very much, Carrie. Hello, everyone. I'll start off by talking about property graphs and how they can be used to get new insights into your data. Our standard safe harbor statement. So one way to think about graphs is to think about graphs as a different way of modeling your data. So you can model your data entities as nodes in a graph, and the relationships between these nodes as edges in a graph. So when you model your data this way as nodes and edges, you're able to apply graph algorithms and other graph analytics techniques to your graph to get new and additional insights into your data. So graph analytics can add a new dimension to your data analytics. So now let's take a look at some examples of this. I mean, what do I mean when I say graph analytics and the types of insights it can provide into your data? So here's a simple example. If you're consider that you're modeling a social network as a graph, the simple algorithm of counting the number of edges connecting to a node gives you some idea of the influence that node has in the network. So higher the number of edges coming in, probably more influential is the node. Now let's take the next, a different algorithm called the PageRank algorithm, which also is used to identify influencers in a network and for other applications. But it is a little more sophisticated than just counting the number of edges in a network, because it not only counts the number of edges coming to a node, it also looks at the importance of the nodes these edges are coming from. In other words, it computes PageRank by not just looking at the number of people you know, but the number of important people you know. And this has applications in a wide variety of use cases, identifying the important nodes in a network based on the importance of the nodes it is connected to. Graphs are also very good at identifying things like tightly connected components. So when you model your data as a graph, you're likely to find that some parts of the graph are more tightly connected amongst themselves than with other parts of the graph. So for example, you can have a subgraph or a community where the nodes are more tightly connected to each other than they are to other parts of the graph. This has, again, applications in a wide variety of use cases. For example, if you think of a subscription service, and it's used to identify churn in a subscription service. For example, if I have a subscription service and I decide to opt out of it, people in my tightly connected subcomponent, that is, could be my friends and family, are also likely to switch services. So this helps the enterprise, the business, identify before the churn happens who is likely to leave the service. And then we have the nodes connecting these subgraphs to each other. So when you have a node, this particular node is important not by the number of edges connecting to this node, but by the fact that it is connecting different subgraphs in this larger graph. So when you're analyzing data, perhaps in an electrical grid network, it is useful to identify these nodes, which would be the nodes you should address first in case of an outage and so on. I mean, they're important because they're connecting different parts of the graph, and when you remove this node, the graph can become disconnected. And these nodes are identified by the betweenness centrality algorithm, which is another graph analytics algorithm. And here's an example that visualizes identifying paths in a query. Identifying paths in a query is important in a variety of use cases. For example, if you look at a financial institution where user accounts are modeled as nodes and financial transactions are modeled as edges between these user accounts. It's interesting to ask the question, did a financial transfer happen between this node and this other node, and which are the nodes that were crossed in between? How many hops were there between these two nodes, and so on and so forth? Is there a shortest path between these two nodes? So these are some of the path-based queries that are interesting to ask when you model your data as a graph. So graphs have applications in the financial industry, law enforcement, manufacturing, public sector, pharma, and more. So I'll just add a couple more examples here about how graphs are used in specific industries. So here's an interesting example from manufacturing. When you manufacture a unit of something, let's say a car, you're usually using thousands and thousands of parts. For example, a car has 30,000 parts. Modeling the bill of materials as a graph helps manufacturers identify dependencies and helps identify which components impact which other components. For example, you see here, this component at the bottom is used by this component and this component and so on. And the same part is again used by all of these other components following this other path in the graph. So it's useful for manufacturers to model this data as a graph so that they can see that what is the financial impact of changing this particular component. What does it mean when I change this component? How many of this component do I need for manufacturing other components in the bill of materials that I have, and so on and so forth. And they're finding advantages in modeling this data as a graph. Here's a customer 360 example where, once again, user accounts are modeled as nodes and financial transactions or transfer of money is modeled as edges. And then you can see, let's say I had a bank account where I receive my salary, and then I transfer my salary into another bank, and then I don't do much else in this bank. So I'm doing all my bill payment and everything in this other bank, and I'm using my account here just as a holding a place. So the bank can identify this based on modeling my money transfers as a graph, and then they can say that, okay, what can we do to to kind of convince Melly to use more of the services in our bank? How can we direct some targeted marketing at her so that she can see the benefit of using some of our other services? So now that we have seen some examples for using graphs and how powerful they can be to get some new insights into your data, let's take a look at how you would develop applications with graphs. One, you need to store the property graph. And if you're using the property graph feature of Oracle database, you have a couple of options. One, you have a specialized graph schema, or you can just use relational tables in the database. Then you need a way to query your data. Because when you're querying graph patterns in the data, you need a way to specify the node, the edge, and specific patterns. So maybe you're looking for 2-hop patterns in a path. You need a way to specify the 2-hop pattern. So the query language which the Oracle database product has is the property graph query language that allows you to specify graph patterns in a query. And then you need to have a way to analyze your graph. So apply these algorithms, the PageRank algorithm, the betweenness centrality algorithm, and so on. Apply these algorithms to your graph. So query, analysis, and then visualization. Developers also need a way to visualize the results. They will also need to programmatically extract the results and use them further down in the workflow. And they also maybe need a way to visualize the results so they can explore the results in a graph UI. So here are some examples of the queries that you can specify using the property graph query language. You can see here the lines in red are the graph patterns that are specifying, for example, find me all employees that have a relationship works for. And this is it's couched within the select clause. You have the select query, and then you have the match clause. Similarly, in the second example, you have a select statement, you have the where clause, and then you have the graph pattern within this query. So the property graph query language allows you to include graph patterns in a SQL-like language to make it easy for SQL developers to start writing graph queries. So here are some examples of algorithms used in graph analytics. You have the different categories, detecting communities, identifying paths, identifying importance of a node, and so on. And each of these algorithms has different flavors depending on what exactly you want to do. So what we have as part of the Oracle database feature is we have APIs to use these algorithms. So these are pre-built algorithms, so you can just, for example, call the PageRank algorithm on your graph, or you can call the betweenness centrality algorithm on your graph. So you can generate the PageRank values and so on, so that you can easily apply analytics algorithms to your graph. And then once you have analyzed the graph, you can then display the graph using the graph visualization tool or some such tool. Here we are again, I'm showing the graph with the PageRank values visually by showing that the size of each node is proportional to the PageRank value. So larger the size of the node, higher the PageRank value. So you can visually, intuitively, immediately identify which are the important nodes in a graph. So with that, I would like to hand this over to Stanka to talk about how graphs are used at Paysafe and why it's important for them.
Thank you, Melly. I will just explain, after you know what a property graph is, I'll give another example from the financial sector, how property graph can be very important and useful for fraud detection. I'll first start with a few words about Paysafe, my company. We have been in the fintech space for the last 20 years and growing up to close to 4,000 people worldwide. We are the leading specialized payment solution globally and the 5th largest non-banking financial institution in the USA alone, processing billions of transactions in terms of volumes. Popular brands include Skrill, NetTeller, NetBanks, and Paysafe cards. And maybe the last most important sentence is that the payment should happen really, really fast, in less than a second, in order to avoid bad customer experience. For each and every payment, we need to answer this critical question. Should we process the payment or not? And any payment must be classified in one of these three categories. If the payment looks legitimate, we will allow it. On the contrary, if the payment looks suspicious, the system declines it. And we cannot be too optimistic, since if customer finds by surprise unauthorized transaction in his bank statement, he may initiate for transaction reversal, and this will result in a chargeback. We cannot be on the safe side and declining any payment, because our money are earned from process, not declined payments. So we need to balance also between fraud protection and negative customer experience. Recently, Visa and MasterCard have changed their chargeback monitoring program. This was actually changed in last October. In general, the thresholds of the maximum allowed chargebacks per account were further decreased. These new thresholds encourage online merchants to ramp up their fraud protection. And if a merchant is not below the threshold within the last 12 months, they may be banned from Visa's or MasterCard payment system, and hence will no longer be allowed to accept Visa or MasterCard payment in their own shop. So fraud is really a huge problem. There are always going to be payments that we are not quite sure should we process them or not. They neither seem that much suspicious, neither legitimate. And for those kind of payments, we make additional checks and verification. But in some cases, even after the checks, we may not be quite sure what to do, and we enter a manual review phase. And manual review is always a problem, since a human needs to decide should we process or not. And as many payments we process, we need more anti-fraud officers, which is not good. So we have defined two challenges for the manual review phase. We have to reduce the manual review time. When a transaction enters the manual review phase, we need to get out of it as fast as possible. And we have decided to go with powerful visualization tools, actually on top of Oracle Property Graph that Melio just displayed to you. And this facilitates the analysis of fraudulent behavior in networks. The other challenge we have is to reduce the manual review count, to reduce as much as possible the payments that go into manual review phase. We have quite a lot of interesting experiments done with a machine learning combined with graphs. You can see a lot of that on the Data and Analytics Summit. I have just prepared a little bit of metrics showing that you may think that manual review is something from the past, but it still happens on a large scale. We can see that each year the percent of manual review decreases, but in the meantime, the volume of the payment is increasing. So while merchants are putting a lot of efforts in their anti-fraud engines, online payments volume grows rapidly. So for the first challenge, to reduce the manual review time, we use powerful visualization and analytics tool on top of Oracle Property Graph. Here is an example of money laundering activity. Money laundering, it's interesting, I just share the definition. Money laundering is the process of concealing the origin of money obtained illegally. And by definition, money laundering consists of three phases: placement, layering, integration. And placement is where the dirty money are put into a legitimate system. Actually, on the left, you can see the layering phase, where the source of the money is concealed through a series of transactions. The yellow dot here sends a lot of, let's say this is the customer under investigation, that sends many transactions to many accounts. So first I forgot to explain what is the structure of the graph. Actually similar to the one that Meli told you about. The nodes are the customer accounts and the payments are the edges. So you can visually see very well the layering phase, how the customer under investigation sends many payments to different accounts and then accumulates all the payments in one. Then comes the integration phase, where the now laundered money can be used for legitimate purposes. And before, we used to do that in a tabular data. It was really hard to spot multi-hop relations. Now the payments flow activity is transparent and readable. actually, when you have a multi-hop relations, it's a graph problem. In our presentation in a Data Analytics Summit, you will see some interesting benchmarks comparing the time to visualize the payment multi-hop relation in a relational database compared to the in-memory property graph engine of Oracle. For some really tough cases, just visualizing this graph on the right up to the fourth hop, it took 4 hours, and we have really good hardware resources. Where on the left, comparing to the in-memory property graph of Oracle, it took seconds. So we believe that modern anti-fraud engines will be a synergy of all these three technologies: graph databases, machine learning, and rule engines. Rule engines are the old school approach to fraud detections. It's very popular since engines can be managed by humans, but the rule base tends to grow sometimes up to thousands of rules, which are really hard to manage. Also hard to manage how to manage outdated rules that are not longer relevant. And it's really slow to spot a new fraud pattern and implement it as a rule. Also, rules are one size fits it all, so many legitimate users will potentially be blocked. But still, rule engines are needed because of velocity and regulation checks. Machine learning is good for identifying new fraudulent paths, yet it lacks context on multi-hop relations, where graph databases really shine. And actually, graph databases are invented to solve the performance problem on connected data. Speaking about performance, graph database enables fast and effective real-time link queries. And the best time to stop the fraud is during the payment execution. That's why we need to make the decision in milliseconds. And here is just an example how machine learning and rule engine and graph can be incorporated together. Machine learning models can pass the probability of a payment being fraud or not to the rule engine. Graph queries, PGQL queries that you've shown in the previous slides that Melly showed you, the result of the PGQL query can be passed as a connected multi-hop oriented feature to machine learning models. These features that are passed from the graph actually tend to be highly predictive. Also, we can query the graph database the same way we query the relational database and make decisions upon that in the fraud screening process. Also, we use the analytics that Melly showed you. For example, PageRank, community detections. There are many more out of the box in the property graph product. You will see that how we use that if you go on the presentation anyway. They're pretty straightforward. You just call the algorithm. You don't need to implement the huge math behind that. You just call the function. So the more we have actually we had a breakthrough when we realized that our customer payment network is a graph. The more we have experimented with the Oracle property graph, the more ideas we got. We have interesting results in combining machine learning with graphs, also experimenting with homogeneous and heterogeneous graph. Homogeneous graph is where you have one type of nodes. The graph that I've shown you before was homogeneous because it had only type of customers. The edges were payments, but only one type of node. Heterogeneous is where you have more type of nodes. For example, put the information about the customer as a separate node, about the mobile, the location. This also can be separate node. We have interesting example about heterogeneous graph on our presentation in Analytics and Data Summit. One of the topic I really like is examining network evolution. For example, detecting the fastest growing customer networks. In the pictures, you may see customer network growing really fast in a given period. These particular networks grow by amount, but we can examine different properties like number of edges, vertices. We can see when the community, you can see on the left, we can see when the community evolved. And actually we do this analysis by PGQL queries. Okay, Melly, please go for it. Thank you for your attention.
Thank you, Stanka. That was a great description of how graphs are used in your organization, and in particular the performance and the new ideas that you're getting. Very interesting to hear. So I will wrap up by talking about RDF graphs. So RDF graphs are a different graph model. I mean, property graphs is something we hear about a lot now. RDF graphs have been around for several years now, I think over 15 plus years. The World Wide Web Consortium defined a set of standards for representing data as a graph. That includes an RDF data model and a Sparkle query language. Just like I mentioned, the Property Graph query language for querying property graphs, we have the Sparkle standard for querying RDF graphs. And then the Web Ontology language for representing facts and deriving new information from these facts. The idea of the RDF data model was, among other things, have a way to represent individual data entities in a unique way. So you assign unique URIs to data instances. And this makes RDF an ideal choice for linking data sources across multiple data sets. And that's what our customers are using RDF technology today. And that's what they're using it for today. And RDF also has formal semantics, providing a good basis for knowledge graphs. And by knowledge graphs, I mean a way to represent complex set of information belonging to a specific domain. So when you're modeling data with RDF graphs, once again, the data is a graph, so you have nodes and edges. And there are some differences that I'll quickly highlight here. Each data instance has a unique URI, and then you can categorize data instances or data entities into classes. Like, for example, everyone is an employee, or everyone is an Oracle employee, and so on. So because you can identify, you can categorize data entities as classes, you can then have rules on these classes, which helps you identify new information about your data. So if you take a look at the fragment of the graph I started off with in the property graph example, you have Daniel. Daniel works for Molly. And you can see here that Daniel is of type Oracle employee. And the Oracle employee is a subclass of employee. So from this, you can infer that Daniel is of type employee. So you took these two facts, that Daniel is of type Oracle employee and Oracle employee is a subclass of employee. From there, you can derive that Daniel is of type employee. So this is just a small example of the things you can do with RDF graphs. And you can also have relationships between properties, and they, for example, here the works for property can be a sub-property of reports to. So when we say Daniel works for Molly, then it means that Daniel reports to Molly. So when you're developing applications with RDF graphs, you need a way to store a graph. And once again, the Oracle Graph feature has a specialized schema to store RDF graphs in the database. And we also need the query language, which would be the Sparkle standard, which we have full support for. And also we have a support for running Sparkle within SQL to query RDF graphs. You can also view existing relational data as a graph, so you don't have to move your data. You can just keep your data in the tables, but view the data as an RDF graph. And you can use ontologies to represent information. So ontologies is, you can think of that as a basic knowledge graph. It's a way to represent information, to make it easily shareable and reusable. And we work with partners to visualize results from graph queries. So we have here at the IND Summit as well, we have a couple of these customers coming and talking about how they're using RDF. The National Statistical Agency from Japan is coming, and as I was saying, RDF is useful for sharing information because it's published with standards. So government agencies find it a good way to share information with the citizens and integrating data from a variety of sources. So a lot of these features are also available in the Oracle Cloud, in the Database Cloud Service, Autonomous Cloud Service, and so on. And we also have on our roadmap a fully managed automated graph cloud service coming later this year. So just a shout out to the Spatial and Graph Special Interest Group. We're going to have special meetings at the IND Summit. It's useful for you to engage in. You can talk to your peers about the graph problems they have and so on. So if you're going to be at the summit, please do look out for these special SIG events. And with that, here are the links that hopefully you'll find useful. Over to you, Carrie.
Great, thank you so much. We do actually have two questions, one from Mark. The installation of 20.1 is 1.2, and then there's a website listed here. I ask as 4 dot just says configure the server by modifying the files under etc/Oracle Graph/graph. Do you see the question? Are you able to answer that?
Yes.
Or would you like to send an email?
I think I'd like to send an email for this. So I think the question is simple. Just says configure the server. Yeah, it should be just a simple configuration step for this new packaging that we have. And I'll be happy to send an email with more details to answering that question.
Wonderful. We will go ahead. Mark, she will send you an email as soon as the presentation is over. We have another question from Evgeny. I apologize if I pronounced that wrong. Where can I find labs for self-study? The location?
That's a great question. So I would recommend going to some of these links and start with the documentation. We have a quick start in the documentation that helps you install the product and run a few examples. And we're going to keep adding new examples to the blog and so on. So keep taking back there. But starting with the documentation is the best place to start right now. The first chapter has some quick starts.
Excellent. And then just so everybody knows, I did go ahead and post the helpful links in the comment section for everyone, so feel free to copy those and you can visit them after the presentation. And then I have a question from Nasir Rana. Where can I obtain a recording of the session? I can answer that. You can obtain it on the Analytics and Data Summit website, which is analyticsanddatasummit.org. And if you just do a Google search of the Analytics and Data Summit, we will have that up. It usually takes a couple of hours for us to get it converted from Zoom, but it should be up for sure by the end of the day. And then you can also go to our YouTube channel, Analytics and Data Summit YouTube channel, where all of our other TechCasts have been posted. And then we have a question from Barry. We'll take one last question, and it is, can graph visualization be embedded in Apex?
That's an excellent question. Not at this current release, but embedding graph visualization in other Oracle products is something that is on our roadmap. But what you can do today is you can run your PTQL queries or the analytics. You can get the results in programmatically or in tabular form, and then feed that into other tools such as Apex.
Wonderful. Well, those are all of our questions for the day. Go ahead.
I just want to add about our visualization. We use Cytoscape.js and we use the PGQL query below because in order to make a separate application, but as mainly shown, there are separate visualization tools. Sorry,
Great.
Go ahead.
Okay. Well, that concludes our TechCast for today. We hopefully will see you next week at the Analytics and Data Summit at the Oracle Santa Clara campus. Otherwise, we look forward to you joining us in March for Rita Noonan's presentation. We are going to go ahead and sign off. Everyone have a wonderful day. Thank you.